Ever wondered what the real magic is behind Docker? You know, how it stuffs entire applications into these tiny portable boxes that just seem to work anywhere? Well, today, we are pulling back that curtain. We're going to dive in and uncover the secret that powers one of the most revolutionary tools in modern software.
So here's what we've got on tap. We'll kick things off with what Docker actually is. Then we'll reveal its secret weapon, the Linux kernel. From there, we'll get into the nitty-gritty of how it pulls off secure isolation. After that, we'll cover the key advantages and wrap up by talking about where Docker hits its limits.
All right, first up, Section 1. What is Docker really? Let's cut through all the hype and build a real understanding of what we're talking about.
Right. It's a word you hear thrown around constantly in tech circles. But what does it mean? Is it the company? Is it a specific tool? Is it the container itself? It can get a little confusing, so let's clear that up right now. Okay, here's the key. When people say Docker, they're usually talking about the technology that creates and runs these things called Linux containers. Just think of a container as this perfectly self-contained little box. Inside, you have your application and literally everything it needs to run. All its code, its libraries, its settings, completely isolated from everything else.
Now this slide is where you see the genius. Look at the difference between containers and old-school virtual machines, or VMs. A VM needs a whole new guest operating system for every single application. That's why they're massive. We're talking gigabytes. But Docker containers, they all cleverly share the host operating system's kernel. And that's the secret sauce. It makes them super lightweight, just megabytes in size, and lets them fire up in seconds, not minutes. This efficiency isn't just an improvement, it's a complete game changer.
Which brings us perfectly to our next section. We're about to meet the real powerhouse behind all that incredible Docker efficiency.
And here it is, the big reveal. The magic of Docker isn't some brand new technology they invented from thin air. Docker's true brilliance was in figuring out how to masterfully use incredibly powerful features that were already built right into Linux all along. And at the very heart of that is the Linux kernel. You can think of the kernel as the brain of the operating system. It's the ultimate traffic cop, managing all the system's resources, the CPU, the memory, all the hardware. It's the fundamental layer that software talks to, and it's the foundation upon which Docker builds its entire world of containers.
So the big question is, how does Docker actually use the kernel to create these perfectly isolated little boxes? This is where we get into the really cool technical details. Section 3. Secure isolation with namespaces. Okay, the first key kernel feature is called namespaces. The best way to think of a namespace is like a soundproof room with one-way mirrors for walls. Inside that room, a process has its own private, exclusive view of the system. It sees its own process list, its own network, its own file system. It has absolutely no idea that there are other processes running in other rooms right next door, even though they're all on the same computer, using the same kernel. This is the absolute core of how container isolation works.
Now, the other piece of this puzzle is something called control groups, or C groups. So if namespaces give a container its own private view of the world, C groups are what control how much of the world's resources it gets to use. This is absolutely crucial. It's what stops one greedy container from eating up all the CPU or memory and bringing all the other containers on the machine to a grinding halt.
So let's put it all together. It all starts with that shared host Linux kernel. Then, when you launch a container, Docker basically asks the kernel, hey, can you build me a new isolated room, a new set of namespaces for this process? And the kernel does it. The application then boots up inside that room, completely sandboxed. From its perspective, it looks like it has the entire machine all to itself.
And this powerful separation is really the foundation of Docker's security model. As you can see, because every container is walled off, a process in one can't see or mess with processes in another. It gets its own private file system, it even gets its own private virtual network. It's security through strict compartmentalization.
But, and this is a big but, it's not a perfect fortress. The single biggest risk is the shared kernel. If an attacker finds a serious vulnerability in the Linux kernel itself, they could potentially escape the container and take over the entire host machine, and by extension, every other container on it. On top of that, the Docker service itself, the daemon, usually runs with the highest possible system privileges, making it a very tempting target for attackers.
Okay, so now that we know how it all works under the hood, let's talk about why. Why did this technology completely take over the software development world? Let's get into Section 4, the key advantages.
The benefits you get from this kernel-sharing design are just huge. Because containers are so small and self-contained, they're perfect for microservice architectures. You can update one tiny piece of your app without touching anything else. You get amazing version control, so you can roll back to a previous version in an instant if something goes wrong. But the real headline, the one advantage that changes everything, is pure, unadulterated speed.
And that's not just marketing speak, it's the truth. I mean, just think about the old way of doing things. You'd have to order servers, wait for them to show up, install the OS, configure everything. It could literally take days or even weeks.
With Docker, it's seconds. You can spin up a completely new, perfectly configured instance of your entire application almost instantly. This didn't just speed things up, it completely transformed the entire pace of how we build and ship software. But what happens when you go from running a few containers to, say, a few thousand? Well, that brings us to our final section, the limits of Docker. See, Docker is absolutely brilliant at creating and managing individual containers on a single machine. But when your application is a massive, sprawling system spread across hundreds or thousands of containers, just managing them all, making sure they can talk to each other, scaling them up and down, checking if they're healthy, it becomes an unbelievably complex nightmare.
And that is precisely the problem that a tool like Kubernetes was built to solve. If you think of Docker as the tool that builds the individual shipping containers, Kubernetes is the giant crane and logistics system that manages the entire port. It automates the incredibly complex job of deploying, scaling, and managing all those containers at a massive scale, making sure the whole application runs like a well-oiled machine.
So from its clever use of core Linux kernel features to the whole new challenges it creates at massive scale, the container revolution is clearly here to stay. And it forces us to ask a really big question. Is this modular, portable, and ridiculously fast approach just a passing trend? Or is it fundamentally the way all software is going to be built and run from now on? It's definitely something to think about.